Hi everyone. Now we are going to be continuing with the programming, and the next sensor that we are going to be looking into is the temperature sensor. Okay, so this temperature sensor, as the terminology represents, is going to be measuring the temperature around us. Okay, and the most commonly used temperature sensor in the world is the LM35. Okay, it is accurate enough, and it has the most simplest connection that can be. You don't have any complex connection, and the programming is very simple. So what is this temperature sensor? It is just a device like a BJT transistor. It has three terminals over there, in which one terminal is connected to the power supply, one terminal is connected to the ground, and the other terminal is connected to one of the pins of my Arduino. Okay. So you may be aware that the data from the Arduino is not going to be going into this temperature sensor. You are reading real-time temperature from the temperature sensor, and you are going to give it to the particular Arduino microcontroller. So it is an input pin over here. So the Arduino, it is going to read the input from the particular temperature sensor. So that is the first condition that you need to know. Next condition that you need to remember before programming is that you should know that whether this data temperature is going to be digital in nature or analog in nature. Okay. You will have temperature around 27 degree, 30 degree, 32, 34 degree. It will be a variable value. It is not fixed to two different values only. If you have only two values that can be represented, you can connect it to a digital pin. But the temperature, as you see around you, is not a fixed value. It is not having only an upper limit or a lower limit. It does not have only those two values. It can be a variable quantity. So you will have to connect this temperature sensor to an analog pin. Okay. So by default, the analog pin is an input pin only in the Micro Uno here. Okay. So you will be connecting that particular third pin to this particular analog input pin over here. Okay. So you have three pins over here, and the leftmost pin is connected to the power supply, the 3.3 volt. The other one is connected, the center pin is connected to the particular analog input pin, and the black color wire that you see over here, the third pin is connected to the particular ground over here. And in this temperature sensor, it will be having one curved surface and one flat surface. Okay, when you hold it in your hand, you will have one side being curved and the other one being flat over here. This particular surface that is seen in front of you is the flat surface. Okay, so you have to make sure that the particular temperature sensor is placed accordingly. Okay, and this same connection is represented in a schematic over here, and in this schematic you can see that the temperature sensor is having one end connected to the particular supply over here, the other one is connected to the ground, and the center terminal is connected to the particular analog input pin over here. You are using the analog pin A0 over here for our example. So let us look at this particular program over here. So you are going to be connecting this particular conditions over here, and first you are going to declare a particular data type, and that particular data type you may have temperatures which is 31.5, 31.9, and so on. So decimal values will come into picture. So to represent decimal values, you are having a particular variable temp declared in float. Okay, it is declared in floating point over here. Next, what is this temp pin over here? This temp pin is particular value of my A0 pin over here, and that particular temp pin value is equal to 0. Okay, so which means that I'm going to read the particular value of my pin 0 here, which is my A0 pin. Okay, so the data that is read from my particular A0 pin is stored in which variable? It is stored in temp pin over here. So I'm having two different lines. That's the only difference. I'm declaring the integer data type over here in one line, and next I'm going to call the particular value of temp pin in another line over here. Okay. So what is my initialization part is done. Please remember the initialization part should be done before the void setup. If you are doing declaring any data type and so on, the library files, everything should be given before the void setup. Next one is your void setup, and you'll be having the serial begin, and the baud rate used over here is 9600. Why am I giving the serial begin? Is because I'm going to print the temperature that is being read by the temperature sensor LM35. I'm going to print it on my particular serial monitor. Okay, so I'm going to be using a serial begin over here. Next one is my particular loop. Okay, what is going to be happening in my loop again and again? I'm going to read the particular temperature sensor value from my temp pin. What is my temp pin? It is connected to which pin? It is connected to pin number A0. So I'm going to read. And am I going to digital read it or analog read it? You know you've connected it to the analog pin, so you have to analog read this. Please remember the analog pin can also be used as a digital pin. Please, and don't forget that. Okay, if you have used 13 digital pins and for your particular project you are not having sufficient analog pins, sorry, digital pins over there, you can use your particular A0 to A5 as digital pins also. Okay, this analog, you know that digital cannot be converted to analog in nature. You can use this analog as a digital also. So, but the only thing is that you cannot put out data. You can only take in data from this A0 to A5. You cannot take out data from A0 to A5. That is the only thing here. So you will have to specify whether you're digital reading the data from Tempin or analog reading the data from Tempin. If you take digital read from the Tempin though being analog in nature, you will be reading only digital data. You will be reading a maximum 0 and 1, which means you will be not be getting any correct answers over here. So analog read is the one that you will be providing over here. Okay. And you will have to implement, this is just a passive device over here. Please remember it is taking a real-time value physical quantity, and that physical quantity is not the temperature directly. Okay, so you need to convert it using some particular formula to make sure that you get the temperature. And what is the universal formula that is being used for this LM35 sensor is temperature is equal to, that is now the value that is read from the temp pin is stored in the variable temp. So that particular temp is now multiplied by 0.48828125. So this particular value multiplied with temp will give you the updated temp value. Okay. So this updated temp value is nothing but the temperature in Celsius only. If you want to convert it into Farad, you need to give the formula for Celsius to Farad conversion also. You can get the data online. Okay. So normal one, people refer the temperature with respect to the Celsius value. So we will be looking into that example over here. So what is my next step? Serial print. So serial print is what do I have to print on my serial monitor? First thing that I will be putting on my serial monitor is the temperature is equal to this temperature equal to. After that, what should be specified over here? My serial print temp. I did not give print ln, please remember. I gave only print, so which means that on the same line, what is to be printed next? Temp. So this temp will be printed after this equal to over here. Okay. And that particular temp value, after that, what am I going to give? This particular serial print degree Celsius. Whatever the temperature that is specified over here is in degree Celsius. So I'm going to give this particular value of degrees over here. Okay. And so temp equal to some degree Celsius is going to be coming in one line. So the next temperature reading is going to take place after 1 second. And should it be printed on the same line? I would not want it to be printed on the same line. I would rather want the new reading to be printed on the next line. So for that particular condition, I will be using serial.print ln, and I'm going to be giving that over here for the next line condition. So I hope you're able to understand how I am going to analogically read a particular temperature value, converting that real physical quantity into a particular electrical quantity over here. That is what a sensor is all about. And from that electrical quantity, I'm going to be converting it using a formula and get the real temperature using this LM35. So I hope you are able to understand that. So next sensor that we are going to be looking into for now is the water detector sensor. Okay. So this sensor over here, it is a long and flat sensor over here, which is going to be used for detecting water. Okay. So you know that water is a conductor over here. So what is happening over here? Water being a conductor, if water falls over here, there will be a conducting medium over here. And when it is starting to conduct, the current starts to flow. And when the current starts to flow, what will happen? It will read a particular value. When it reads a particular value, you will be able to give the conditions accordingly. So if there is no water over here, no conduction is taking place. When no conduction is taking place, the value is 0. When there is water over here, you will see that there is conduction, and due to that conduction, there is going to be current flow, and due to that current flow, it will be a logic 1 over here, and that particular value is used for the particular output condition. Okay, so you're detecting water flow, that is the condition. You're detecting water is there or not. Okay, so this is your particular code over here, and this is your particular schematic over here. You have 3 pins over here. One is connected to the digital pin, another one is connected to your virtual ground, the supply, and the other one is connected to your particular ground over here. So one is connected to supply, one is connected to ground, and one is connected to the pin over here. Okay. So you're going to define. So please remember, when you are using this particular sensor over here, you will have to define it by a particular library file, that is as define grow water sensor 8. Okay. So you will have to add this particular file over there into your particular particular program. Okay. So this grow water sensor 8 is the one that you are using here, and this is connected to and you are having a particular LED over here that is connected to pin number 9. Okay, so that you're connecting it to pin number 9. This particular grow water sensor is connected to pin number 8 over here. So grow water sensor is connected to pin number 8, and there is a particular value of LED is connected to pin number 9 over here. So you are declaring which one is the input and which one is the output over here. So pin mode grow water sensor is my input pin. So I'm getting the data from this particular sensor and putting it over here. So it is an input pin, whereas this particular LED is the output pin over here. Then we'll point my loop over here. In my particular loop, what am I going to do? I'm going to read the particular data available. So if the particular digital read value, that is my gross water sensor value, is low. Okay, if it is low, then digital write LED equal to high. Okay, so what is happening over here? The water sensor will switch low when water is detected. Okay, if it will switch low here, because you can see that if it is conducting, what will happen? If water is available, it will start conducting. If it is starting to conduct, plus to minus, there is a short circuit over here. If there is a short circuit over here, what is happening? You will understand that it will be low. Okay, because all the current is flowing to ground over here, so it is equivalent to low. So if it is low here, you can see that with a particular water is available, so you will digitally write the particular value of your LED to high over here. Similarly, what you're going to do next over here, if the particular value is high over here, what you're going to do, you're going to be putting the value of your LED to be low, telling that if it is high means there is no water available, because from the power supply to the ground there is no connectivity over here. So there is only a high value available over here, which is read by this particular list. You can see the short circuit over here. So the same place is available over here, which means a high voltage is being made over here. If this particular water is available over here, the particular plus to minus conductivity is short circuited, and what happens? There is no supply provided to S pin over here, which means it is low. So when it is low, LED is on, which says that water is available. When this water sensor value is high, it means that no water is available and the LED will be glowing low here. So this is what is happening in this particular water detector sensor. So I hope you were able to understand that. Next is a PIR sensor. PIR is proximity infrared sensor. Okay, so it means that it is detecting motion movement depending upon the IR radiation that is emitted from it. Okay, so this is a simple 3-pin device which is having a semicircular device offset on top, which is the PIR motion sensor. That sensor is mounted on this particular PCB over here, and it is connected to 3 main pins. So one is my supply and one is my ground, and the other one is my output pin from the PIR sensor, which is given to this Arduino here. Okay, I have a supply, I have a ground. This supply is given to the 5 of my particular 5 volt of my Arduino. This ground is connected to the ground of my Arduino, and this output is connected to one of my digital pins over here. And here I'm connecting it to my particular pin number 2. So that is what you can see from this particular program here. I hope you can try to understand what is happening in this program on your own. Okay, so probably we'll look into this in detail in the next particular optional available. So try to go through this particular program and understand from the previous programs explained to you. Try to understand what is happening in this particular PIR sensor over here. Okay, see you then.